Alrighty, good morning, good afternoon, good evening, wherever you may be. Today I wanted to present on a open source load testing tool called Locust. I've been coming across this more and more because I've been spending a lot of time making APIs for the company that I'm currently contracted to. It's Aliander in the Netherlands. And so I thought it would be fun to kind of show how easy it is to use. And it happens to also be part of a larger project that I'm working on, so I thought this was a sort of nice way to do a middle ground mini tutorial as I work on this larger project. Yeah, so essentially this falls under this larger project, which is essentially looking at which frameworks are the quickest, easiest to use, are small or not, documentation, and this then of course falls under load testing, and to some extent indicates error handling with regards to the frameworks. And then I have a big old list of frameworks that I need to get through. But that's for another day. But yeah, if you see any that you think are missing and would like to be included in this comparison, please let me know. I would be curious. But yeah, this is about Locust, so I wanted to quickly show you what I've got running and how it kind of works. But first, we are going to be testing today a fast API-sqlalchemy setup. Has a bunch of different endpoints. It uses some complaints data, just to give. Oh no! Of course I've turned it off. All right, let's just start from scratch because it always goes poorly as soon as you try and start from somewhere in the middle. So this is the script so the back end of all of this is a Postgres database. It consists of two tables, a complaints table and a prices table. The complaints table is taken from a Kaggle dataset, which is in the README of this repository. And so for the moment, we're just going to get rid of everything, and then I can show you what sort of data we're playing with here. So this is the complaints data. It has a bit jumpy today, excuse me. It has the date received, the products, some general info about consumer stuff, where the company's from, blah 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 blah. Basically, the main thing we're caring about is the complaint ID, because that is what we're using to match the price on. And it's in the future, maybe it's interesting to know what the issues are, which is also then what this Kaggle thing was all about. Here's the general overview. We have some missings here and there, but it doesn't matter too much for what we're trying to do here. And then the price data frame is just a set of random numbers, random uniform numbers between 0 and 100. Yes, so having run this script, we should hopefully have a Postgres table. Also I should have mentioned I have all of this running in Docker. It uses a Docker Compose file that I've written, which has pgadmin, the Postgres container itself, and then the API that we're looking at the moment. In the big API comparison, I will go more into depth into how to deploy this stuff, but just know that it's using that file, and the command is this. That's now what we're currently running. Cool. But to summarize, now we have our data. We have our Fast API running on port 8080, which is where we are here in the docs. The nice thing with Fast API is it comes with docs out of the box, Swagger documentation with regular open API JSON, but I digress. And then just to check that the API is running, we can attempt to get the root, which gives us our hello world sort of thing. And we can then also see in the logs of this thing, yeah, we have a get, and it was a 200. So that seems fairly okay, and since I've added data back, hopefully now, we should get some complaints data too. There we go. So this is just essentially give me the first X amount. It responds with a list of dictionaries or a JSON array. I come from the Python world, so my language for what we're talking about may be a bit off, but in any case, you get what I mean. These sorts of ones in a big list of stuff. Yeah, and there's a bunch of other endpoints because we're just testing out how quick and how much each endpoint can take. Cool. Yeah, and then a little bit more about the Fast API itself. Predominantly, we're just trying out a bunch of different things. This is just a get with a select table limit. This is then per ID, so select where. This is just the first for the price table. This is a select where based on the complaint ID. This is an example of a join. So the goal here is to give select in the complaints table where the complaints are the complaint ID, and then add onto that the corresponding complaint ID that is in the price table. And so it will be a list of one, a dict of one, with that information in. So this is then testing out how quick SQLAlchemy is with the joins, and to some extent Postgres as well then. This is the get all. This is just purely for load, like what happens when you try and pull this endpoint, does it crash everything immediately? Oh yeah, for context, I'm running this on a Mac Mini from 2018. So hardware-wise, that's then what we're dealing with. Oh yeah, here's the create. So insert new information. This is then the get based on the date received. So this is a different select statement where. This is the delete, so delete where the complaint ID is the one provided. Same for the prices. So that's then the code for what you see here. Now I think we have covered enough of the API stuff. If you're curious about APIs in the future, I will have this API comparison as a separate video, and then I will dive much more into how each version works. But for now, the thing we care about is the Locust stuff. And so here is the configuration file. You can do it on multiple different methods. I happen to be using the pyproject.toml approach, but you could have a locust conf, or you could provide everything as a command line stuff. So then here is the various different ways of doing the same thing, and then what each command does. It's a very nice, clean way of doing things. So what we'll be showing off today is, the Locust file. Headless indicates whether or not you want the user interface, the graphical user interface, to be shown or not. Headless is true, doesn't show the graphical user interface. It is possible to set Locust up in a master, is it called slave? Master worker setup, where you can then have multiple sort of hierarchical test frameworks here. So you can then query tons more. this sort of assumes a microservices infrastructure, so with Kubernetes and stuff. Today we're just running it in well, locally actually. In the future I want to include it in the Docker Compose, but this is just from command line, so we are not dealing with any masters and expected workers. This is where the API is located, so for me it happens to be 8080. Make sure you got that right. Users is how many total users you want to emulate using Locust, so how many calls in the end. And then the spawn rate is how quickly it goes from 0 to that amount of users. And then runtime, you can specify seconds, minutes, etc. And this is then how long it runs for. So these three sort of work together to reach the final endpoint that you care about. This is where all the results are saved. So whilst there is a user interface, you can pull CSVs of everything that you will see in the user interface in a moment as well. So this is then per X seconds. I'd have to look off the top of my head. But you'll see all of this in the user interface when we run this. All of this is running from a Locust file, which is just a very simple Python file. And the way that it's set up is that each task corresponds to essentially a call to an API. So here we have our root GET request, which then corresponds to, in this instance, just the regular /. So if we go here and say, just give me this, this is then the call that it's making. And then same for this. So if we say, give me the complaints with the limit equals blah, 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 then you will get what you saw in the docs, but then just the raw data that you've requested. And yeah, so on and so forth. And because this is just regular Python, you can play with it to your heart's content. So for example here, this is an endpoint that will gradually increase the amount of limit that it's looking for. So here we're just using regular NumPy, but it's saying start at 10, limit of 10, and then go up to many, big number, 100,000, and then do it in steps of 10. So yeah, that's then there. And the same sort of idea for every other endpoint that we've got here. Just give me an insert, give me a delete. Everything I should mention that everything in this API is based on query parameters. So I am passing them to the URL, but there is also support within Locust for sending stuff with body as well. So here, for example, there is a client post with the body that you want to post. So that is also available, which is very nice. Yeah, should we actually run this bad boy then, and we can have a quick look to see what's going on? So what I'll be doing is running it locally, and all that really means is that we go to our test suite. This is then where we are. Bum, bum, same thing. And because we have set a PyProject toml, this command is literally running this. This command, is just running this file. So it will be the equivalent of what we're going to do, which is just this. Is the same as running Python, and then your version if you have a version, and then the Python file itself. But because we've set up the PyProject, we can just do this. Which then gives us two things. One, the endpoint that Locust runs on. By default, it's 8089. We can change this if we want, but I think we're fine with it. And then it gives you the version that is running as well. So let us go to localhost 8089. Because we're running with headless is false, we get a nice little UI. Just to show you, if you turn this off, then, if you set this to true, then you will not get the UI. So this is then the command line version of what you will see in the user interface. Essentially showing you a bunch of summary statistics of all of the GET requests that you care about. This is handy if you're running this as part of a pipeline, but because we're doing this as a demo, I think it's quite nice to use the user interface. Excuse me, false. Yeah, so let's go back to where we were. Oh yeah, for the failures, I've added an endpoint called fail that does not exist. So if we go here to our API endpoint, it's funny, I said, let's show this bad boy, and now here I am doing this. We will get this as a response, and then the HTTP error should be the corresponding one that we're talking about. So fail, localhost, and then if we click on what it is, I never use Safari for this. In any case, it's a detail not found, which I think is 500. 404, excuse me, 500. There we go. 404 not found. So we expect to see that in the output of our Locust setup as well, because it doesn't exist. So we're running it. Let's go back to our front end. What we've set in our pipe project is then what is set as the defaults. So we've said 100, 10, and 10 minutes. So this is 100, 10, and then 10 minutes, but it then gives itself in seconds. So yeah, and then we've got our default of 8080. So let's just start then, shall we? So it will ramp up. These are then the overall statistics of what is being currently run. We have the amount of requests, the amount of fails, which of course then for fail we expect to see exactly the same, 32 and 32. As we ramp up, it's likely that the complaints one will start breaking as well, because it's quite a lot of calls towards the end, and running it in a single pod is not going to be able to support that. We have the median time in milliseconds each call takes. So the bigger the request, and also whether it fails or not, will have a direct impact on how long it takes. And then yeah, general summary statistics of that. So essentially this is describing the distribution of the milliseconds that it takes for things to run. This is then the size of the thing that is sent back. You'll notice that this one keeps increasing because we're increasing the limit that we're asking for. Yes, and then this is then requests per second. Yeah, there we are. And then the nice one to see is, of course, the charts, which it does in a very pretty way, I think. We have basically the summary of what we just saw. So this is the amount of requests per second. The smaller this is, the worse your API is able to deal with large loads. For this instance, this will get smaller and smaller because the size of the limit is increasing and is thus then taking longer to deal with. The request, the response times will get higher because of the same reason, and because we've only asked for 100 users, this is then peaking out, so each jump should be around 10. Sometimes it's not bang on, but essentially it should ramp up per the amount of spawn rate that you said. Let's have a look at our failures. We still have yet to fail. There you go, there's the full HTTP error. We have still yet to fail with the large limit, so we will see how that goes. We have no exceptions at the moment, so that's good. This is general ratio per class, so each instance should be represented the same amount, unless you specify that you want to query one more than another in your code. these are then all the CSVs that are being saved locally anyway. These are then these results. So for example, this is currently being appended to every, I think it's every second, maybe a bit quicker. But yeah, so now we see 263, and if we go to a different one and then essentially refresh, we've now gained extra couple rows. So this is verbatim the data that you are seeing in these charts. So if you want to perhaps run Locust in part of your testing pipeline, then save this data somewhere. Ooh, there it goes again. And use it as part of something else later. You can then save the results and then maybe create a dashboard or something that then averages this sort of stuff out. Or yeah, I mean, the world's your oyster. It's basically the joy of having this thing run in Python is that it can be customized to as much as you really want it to. The only limit is really what Python is able to do. So yeah, I think that's the summary of it all. I hope I've shown that this is very simple to use. I hope that, oh, in fact, yeah, let's just real quick. This is then all of the calls that are currently being made as we go. So I think it's quite fun to see. So this is in the back end what Locust is doing. The main thing, of course, is then the complaints limit, because that's then this for loop that we're going through. Have we got any new failures yet? Still no. Interesting. Well, I think that's kind of fun. And shall we see if we can break it now? Because that's always the thing that people want to see. Can we break our API? Oh yeah, then this is in the summary. So this page should match the final UI page. Yeah, so let's see if we can break it. Let's add many, shall we say, 10,000. Spawn them in relatively quickly. Fuck it, let's just go all out. Let's go all out. Oh, I've sworn in a what's it called? A thingy video. So now we've updated, so then this number should increase, which it has. Yeah, cool. Let's give it a go. And let's see how fast API and Postgres can deal with all this. I imagine it will probably struggle. Well, in fact, shall we spawn in with a bit more users? So we go. So then it'll take a little less time to ramp up. And then in the logs, we're getting, we're already, oh boy, we're already getting warnings. Let's have a look to see how things are looking. Oh wow, this is not good. Okay. Okay. It's not as bad as I was expecting. HStop, by the way, is just showing what cores on this thing are running. There are 12, as you can see. And yeah, if it's struggling or not. But it's nice that Locust is warning that that this will affect your results. So yeah, good to be aware of. I think testing in the microservice setup is a nicer way of doing things. We have not many calls. Oh no, I think we've just fully ruined it. That's interesting. Oh, now it's sorting itself out. Oh, because of how long it takes to run. How long it takes to run the all one, probably. Because this returns about 2.5 gig of data. That's a good point. Let's not do that because it's unlikely we will ever reach our endpoint. It's all falling apart immediately. Should never have done this. All right. Let's see if we can meet somewhere in the middle. Oh, excuse me. Test suite, Locust. So we've gotten rid of our all endpoint, which should mean it's not too bad. Let's ramp up to 100, and then just for certainty, let's go 10,000 instead of 100,000, because it is a small guy still. Poor little guy. And then yeah, let's see how it gets on. Now, show me everything, please. 1258 times it. Yeah, I think we're about there then. Yeah, we are cooking again. 1258 times 6. We don't have the logs, so it seems that we've not gone over the limit for my poor machine. So that is promising. The breaking point of fastapi is somewhat interesting though, because it does seem that we have a fairly flat trend across things up until a point in which it just starts struggling all of a sudden. Oh, we've got our log back, so we're reaching sadness already. So we're doing on the failures. Oh, we've got failures on all the endpoints now. There you go. We've got a connection reset error for most things now. What's fail saying? That's also connection reset. Yeah, so that's too much for my machine and fastapi/postgres running in a very small Docker setup. Interesting though, the stability of the amount of requests. The problem is that the problem that we're seeing here is that the amount of requests and the amount of failures per second are exactly the same. So we are likely not getting any results back, which means we've already broken it by doing this. Good to be aware of. Also, these response times are very slow. 30,000 milliseconds, that's what? Yeah, and now my machine's dying again. MS in seconds, what's that? 30 seconds, yeah. So yeah, this is already too much. We flew too close to the sun. Oh my god, it's cooking. All right, let's kill it, because I'm also recording this video, of course, which is then taking up a decent chunk of memory. But yeah, what I would suggest doing is grab this API framework comparison repository. It should be open. I'll double check that it is before the video is live. And give it a go yourself. Try and run it using Kubernetes maybe. Try running it in a machine that isn't your local machine to see what the differences across machines can be. Yeah, and in the future I will come back with a full comparison of all these things so we can see whether or not the problem's my machine or whether or not fastapi cannot handle, cannot go up against the big guns like Go and Rust. So yeah, thank you for your time. I hope this was interesting, and look forward to this big API comparison video that's going to come. Thank you.